Okay, so root 3 over root 250. Yeah, let me give you some help on this one. First, break down the denom. You know, before you do anything else, break down the denom. In other words, what I mean is like use your calculator, 250. Whenever a number ends with a 0, do you remember that means times 10? So that's really 25 times 10. You can use a calculator if you're rusty on some of those times tables. And then the 25, keep breaking it down, 5 times 5, 2 times 5. So kind of clean up the bottom first. If you have the Casio Natural Display, you can just hit the button. So, at least for the bottom, it won't be the whole thing, but at least it'll give you the denominator. So what happens in the denominator then? It's the 2 5s inside lead to 1 5 outside. And what's left inside is the 2 times 5, the 10 inside. So far, so we're not done yet because we still have a root on the bottom we got to get rid of. But so far, so good. Does that make sense? What's happening to there? So I just did the denominator first. And remember, it's 2 for 1. That's the main golden rule we're following in this chapter. 2 5s in, 1 5 out. 2 for 1. That's how you make a jailbreak. 2 in leads to 1 out. And then another 2 and 5 are left over. 2 times 5, 10. They remultiply and stay inside when there's not 2 of them. Okay, now we've got to get rid of the root from the bottom. We're fine with the root in the top. We don't care about that. Doesn't bother us. But they said rationalize the denominator. So go ahead and do one more step. See if you can finish it from there. One more step. Get rid of that root from the bottom. So how do we get rid of that root from the bottom? Yeah, just another root 10, huh? Got to do top and bottom to get balance. Okay, now remember on the top, insider with insider. 3 and 10 can make 30 because they're both insiders, huh? They'll get together. Okay. Now, on the bottom, the 5's an outsider. He stays separate, right? But what are the 2 root 10s going to do? Just make a regular 10. So it's going to be 50 on the bottom when all is said and done. Does that make sense what happened there? The 2 10s in the root lead to 1 10 out of the root, right? The 2 in, 1 out thing. So then that's root 30 over 50. We're done. Okay, we can't reduce that or anything because that 30 is an insider, the 50 is an outsider. No interaction. That's it. Is that okay? Questions on that? So in the end, we're always getting rid of the root from the bottom. All is well? They're getting a little bigger here. I think we can probably reduce this one first. So root 432, root 12. First, divide and reduce. So, like what I mean is, does 4, or maybe does 12 go into 432? I don't know. What's your calculator say? Does 432 divide by 12?
Yeah, 36.
Oh, nice. So just divide them. Now the answer is not just 36. Why not? Why is it not just 36? Well, because the root's still on it, huh? Because it came.
So that's 6.
So it's 6. Excellent. So the answer is actually 6, huh? That good? Because at first you have the root still because the numbers were in root. It came from stuff in roots. So it's still in the root at first, and then the root of 36 is just 6. So that's real nice. We didn't have to do any messing around with multiplying top and bottom by roots and stuff. Is that good? Questions on that? Okay, so we divided them. Okay, let's try that one. So first, divide and reduce. if possible. And I believe it is possible. What I mean is the 75 on the top and the 250 on the bottom, they're both insiders, so they can interact, right? They're both in roots. They're both in the same world. So you can divide top and bottom. What goes into 250 and 75?
Can I do that like a fraction?
Yeah, just like a fraction. That's exactly what I'm meaning. Yeah, what goes into both of them? Is it 25, I think. You can do 5, but you can even do 25, right? That'd even be quicker. Yeah, divide top and bottom by 25. It's root of 3 over the root of 10x, I think. And by the way, that would not be okay what if they gave me this problem and the 75 was originally not in a root? Then they couldn't interact in any way. They're one's an outsider, one's an insider. But anyway, we're good. So keep going. We can't, why is this not just my final answer? Why am I not using that? Right. And the x. We got x. Yeah, so do the whole thing, root 10x top and bottom, right? Because we can't leave roots in the bottom. That's right. So root 10x top and bottom, right? On the top, can I multiply the 3 and the 10x? Yes, they're both insiders. They're both in the same world. So just
Powers cancel.
root 30x. What powers do we have?
Never mind.
Good. And then on the bottom, I have a 10x and another 10x. So remember, what's the golden rule in this whole chapter? What's the main thing we do with roots? 2 in, 1 out. 2 of anything. Could be 2 monkeys in the square root. One's coming out, just to be goofy, but say really anything. So the whole 10x, 2 10x's in, 1 10x out. Just like that. And we're done. Now, why can't we, cancel the x's, for example? Yeah, why can't we cancel those x's? Inside or outside? The whole jail thing, right? This x is inside, he's locked in jail, this one's out. A person on the windshield may be locked in jail. You might not be able to socialize with this. All right, so different worlds, right? Same reason we can't go 10 into 30. There we go. Good? Questions on that one? Is that making sense on this? So what did I do first? I just divided top and bottom by 20. So always try dividing like a normal fraction. Just like Carr was saying, it's just a normal fraction at first. Just reduce it like a normal fraction when they're both insiders. It's the first step. So if you can do that, that's always the easiest thing to do. Okay, let's try this one. Square root of y to the 17th over the square root of xy squared. So let's continue with it's basically a fraction thought. That's true. So what can you do when you have y's in a fraction like that? What do you do with those powers? Remember we can subtract powers? Subtract. Yeah, just go ahead and do that just like you would with any other fraction. They're both insiders. If one of those y's was an outsider, then no, we couldn't interact.
X outside.
Oops. So 17 minus 2. Good for the first step. Just reduce by subtracting the powers. 17 minus 2 is 15.
Can I have a, y go on the outside and single y on the inside?
Do what's that?
Have
For the top one? What do you want to do? Have a bunch of y's come out and leave one inside. Yeah, good idea. That's what we should probably do next. Yeah, let's do that. How do we simplify y to the 15th? Remember what we do with an odd power? Odd powers make it even. Go, So for odd powers, you lower or subtract 1. How about that? Subtract 1, and it's even with 1 more. So in other words, I make it y to the 14th y. Is that making sense there? So that's what I do with the 15. So whenever we have an odd power, remember what we do? We subtract 1 from 15, make it 14 with 1 extra. Remember, because with odd, there's always going to be like odd man out. We're going to leave the odd man in, right? There's always going to be 1 extra left in. And then what do we do with the y to the 14?
Aren't you do you do that before you multiply by x?
You can do it before or after. I'm going to do it at the end. You can do it at either time. Yeah. Everybody see what happened there? So when you have an odd power, I'm going to multiply by the root x in just a second. You could have done it back here if you wanted. At some point, we do need to multiply top and bottom by root x. It doesn't really matter when you do that. At some point, we will need to do that to get rid of the roots. I'm not done yet, but I'm just kind of dealing with the y's right now. So what do odd powers always mean when you have an odd power? See, we like to cut powers in half, don't we? If that was a 16, I would just say y to the 8th in the front, huh? Remember? Because it's 2 for 1. Right? So if I was to go to Target and there were 16 items on sale 2 for 1, I'd pay for 8, wouldn't I? That's why we cut it in half. Well, but you can't cut an odd number in half, so what you do is you lower it by 1. 14 with 1. 15 means 14 with 1 more. Then you cut the 14 in half. And the 1 more has to stay in. Odd is always going to have odd man that stays in. Now, we're not quite done. One more step. We can't leave a root on the bottom. Top and bottom by root x. Right? Could have done that earlier. Doesn't matter when. And we're going to get y to the 7th. You could just go ahead and put the x and the y in the top on the same root. They're both insiders. So they interact. What happens on the bottom? What's root x, root x? Plain x, because 2x is in, makes 1x out. That's the jailbreak, the golden rule, 2 in, 1 out.
Now, we're taking it accept that.
Yeah.
So, looking at that, now going back to the previous question, the number 19, you have root 36, or 30x over 10x. You reduce the 30 also.
Good question. So yeah, the last one was, what was it? Was it the root of 30x over plain 10x?
The finished answer.
Yes.
Right. That was the last one. Yeah, why? Good question. So on the last problem, why did I not reduce? This was the root 30x over 10x. This was the last one. This was the last
Because the x is
problem.
Yeah.
It's the insider-outsider thing. See, this 30x is all in jail, in the root, and the 10x is all walking free. There's no social interaction between outsiders and insiders. So they can't reduce, can't do anything. Does that make sense? So that's why it says, good question. I like Carr's questions. Everybody dialing in with it? That's why on the last problem, I couldn't reduce it any further because the 10x was not in the jail. The 30x was. No interaction at all. No reducing, no canceling, no nothing, to use bad English. No reducing at all.
Is it going to accept the answer?
This one right here?
Yeah.
Yeah, that's the right answer. Yeah. Yeah, and why don't I cancel these x's at the end? Same reason. This x is insider, that x is an outsider. Good on that? Questions? All right, so again, odd powers, what do we, it's going to come up a lot. What do we do with odd powers? Subtract 1, make it even, with 1 extra, and then cut it in half, it comes out. Right? So we always do with odd powers. All right. Okay, so now we're in 8.4. We are adding roots. So 8 root 6 plus 6 root 6. Adding roots. So we've been multiplying roots. So what are the rules for adding roots? Well, when you add roots, you add like roots. It's the same.
So inside, outside, outside?
Well, it's the same as letters with like terms. In other words, what if you had 8x and 6x and you were adding? Just think about letters. Pretend the root is an x. I think that would be the easiest way to learn this because it's exactly the same rules as if that root was an x. So what would you do with 8x plus 6x? What would be the rule? Do you remember? Add them. And is it x squared or just regular x? Regular x, yeah. When do we make x squared? If you were timesing them. But for adding them, you don't, huh? You just add the numbers in the front, the 8 and the 6, and you keep the x as it is, huh? Well, it's the same thing with the root. You just add the numbers in the front, the 8 and the 6 for 14, and you keep the root as it is, and you're done. It's just like adding like terms. It's like roots. That makes sense. It's 8 roots of 6 and 6 more roots of 6. It's 14 roots of 6. It's all well there? Questions on that one? You're right. That's it. It's that easy. 4 root x minus 2 root x. All right, give it a try. Just like roots. Just add or subtract the numbers in the front. Don't change the root at all. Just 2 root x. That's all it is. Starts out easy. It'll get a little more messy. But good so far. So we always do the numbers in the front. 4 roots of x, take away 2 roots of x, is just 2 roots of x. Good? So it's just like roots. Just add the numbers in the front. Okay. So 5 root 20 plus 1 root 5. Okay, now, those are different roots, aren't they? How am I going to add those? You can't just add the numbers in the front, 5 and 1 to get 6, and the roots. You can't do that. They've got to be same roots in order to add them, and they're not. But something needs to be simplified first, huh? What's in that 20? Doesn't that 20 have some stuff in it that I could ship to the front? Yeah. Do that first, and then they're going to end up being like roots, you'll see. So now let's break down that 20. What times what is 20?
210 or 4 or 5.
210 or 4 or 5. You can do it either way you want. I'll just go 210. And then what times what is 10?
5 and
2, 5. So notice what we get there. We get 2 2s and a 5 in that 20, huh? And what's the golden rule for the whole chapter for roots? What's the main thing we're always doing? 2 in, 1 out. So 2 2s inside the root. Send 1 2, and it multiplies. Remember, it's all about multiplying here, right? They were multiplying inside, they'll multiply outside. So that 2 that comes out multiplies the 5 that's already waiting out there in the front. So what's that going to be? 10 in the front now, right? 2 times 5. And what's left inside?
5.
The 5. Plus, and then the other one's just 1 root 5.
So 11 and just root 5.
Yeah. And so then the final, now that they're like roots, we can add them. 11 root 5. Does that make sense what we did there? So we simplified that root 20. 2 2s in, 1 2 out. Hits the 5 that's already in the front. 5, 10. It's all multiplying, right? When it comes to the front, it multiplies what's already out there.
So you just back to the higher one.
Yeah, well, whenever you have a number like any number, you got to check it out and see if there's pairs in there. Because if there, now what if I had, let me ask this question. You bring up a good question on that. What if there was like 5 root 30 instead of 20? Would I break down the 30? Yeah, try it. I'm just changing. I'm saying I'm doing a what if. What if it was a 30 instead of 20? You'd break it down and go 6 times 5 or 3 times 10 or whatever you want. And then 2, 3. So 2, 3, 5. Is there 2 of anything? So then no cleanup. It would just stay as it is. And then there's nothing you could do because those are unlike roots. They couldn't be added. This would be a do nothing problem. See the difference?
It's still the same because when you multiply it, it'll still end up being the same.
Well, this was a different question.
Yeah, no, I understand.
Yeah. So does that make sense? So the reason nothing comes out is because there's not 2 of anything. So basically, whenever you got a number like 20 or 30 or some kind of number that you're not sure about, break it down. If there happens to be 2 of anything, it's got to ship out right away. So that's the golden rule. 2 in, 1 out. On that. All right.
Oh,
Whoops. There's my answer. All right. So here, let me just erase this.
is that another reason why back on the 8.3, why we could break it down?
That other one?
Yeah, the
Root 30x over
over 10.
root 30x over 10x or something like that.
Yeah.
It was all just because the insider outsider thing.
Okay.
Oh yeah, and the 30 won't break down. Yeah, I see what you're saying. That's true also. Yeah, you're right, Carl. Yeah, the 30, if you broke it apart, there's not 2 of anything, so nothing comes to the front. Yeah, that's true also. Yeah.
Okay. So
All right.
if it was 25 instead, we could break it
Yes, exactly. Or if it was 20, we could send some stuff out because 20, as we see right here, has 2 2s. Whoops, I just erased the 2 2s.
So you want it to be broken down if it comes across that.
Yeah, break down any number that ends up having 2 of something. That's exactly the rule. Because if you have 2 of something, it's going to ship out.
Okay,
That's it.
thank you.
Mm-hmm. So why can't you, where are we at? Oh, good question. Yeah, I think I know what your question is. Why? Yeah, good question. I didn't think about that. Why can't we look at these 2 5s inside the root and ship 1 5 outside? That's what you're saying, right? 2 5s. Why did I suddenly stop doing that? Did y'all notice that? That's a good question. They're not times. That's only for multiplied. Yeah, we've shifted gears. This is the adding, subtracting section. Yeah, so really good. Yeah, so the good question. And that's what's confusing. That's what's hard in algebra, huh? Is that you learn like one set of rules, but then next section, it changes because you're adding, subtracting instead of multiplying, dividing, whatever. And then you get to the test, and you got to keep all that straight. That's why you want to use that practice exam just to kind of help you with the mix-up, because that's what's hard, huh? Because you get one thing down, and then they change it up, and then the exam is like one of these and one of those, and back and forth. Yeah, so really good question. It's only times when we do the 2 in, 1 out. It's only if they're times. Good question. When they're added, subtracted, we don't do the 2 in, 1 out. We just do like terms. So you want to put in your mind 2 different thinking caps, so to speak. If you're in multiplying mode, then you want to think 2 in, 1 out. If you're in adding, subtracting mode, you want to think like roots. Different set of rules.
Okay, so basically you want to do the 2 in, 1 out prior to...
Yeah, earlier on.
For the adding and subtracting.
Right.
So the adding and subtracting, the final answer is the final answer.
As long as there's not 2 in, 1 out. Yeah, so right here, so just what you're saying, Car, so on this one, first thing to do is break down that 80, break down that 45. Right? And do the 2 in, 1 out, 2 in, 1 out, break them all down, ship out what you can, and then after all that's over, see if you have like roots that can be subtracted. Because we can't subtract them right now, can we? You can only subtract like roots or add like roots. And they're not like right now, but break them down, I think they will become like.
Bless you, Bruce.
Let's break down that 80. So we good? I broke that 80 all the way down. And then do the 2 in, 1 out. Two twos. Two more twos. So what's up? What's coming out for that 80? It's going to be 4 root 5 out there. Is that good? Because these two twos sent out of 2, these two twos sent out of 2, and this 5 had to stay in. We good to there?
Yeah.
And now what about the 45? Do the same thing on him. 5 times 9, 3 times 3. 2 3s in. 1 3 out, the other 5 stays in.
Is it 1?
Yeah, it's going to be 1 root 5, yeah. We good to there?
5?
1 root 5 or just root 5, right? So then it's 2 times 2 is 4 roots of 5 minus 3. Now they're like roots, huh? Remember, put your adding subtracting mode on. We're not doing 2 root 5s or any of that. We're just saying like roots. 4 roots of 5 minus 3 roots of 5 is 1 root of 5. Or you could just say root 5. Both are good answers on that. Because 1 times root 5 is just root 5. Is that good? Like terms. Yeah, so for adding, subtracting, it's all about like terms. Good. Questions on that? No questions? All right, so the 2 for 1 deal, and then like roots. Okay. All right, so you got to break all those down. Break all those numbers down. Do the 2 for 1. So break down that 27. 3 times 9. 3 times 3. So remember, when you send a 3 to the front, it's going to multiply that 5 that's in the front to be 15, isn't it? There's already a 5 out front from the 27. So 2 3s in, 1 3 out, so 15 root 3. Then break down the 75. 3 times 3/4 is 75 cents. 25 is 5 and 5. So 2 5s in, 1 5 out. What's left over in is a 3. And then the 12. 4 times 3, 2 2. 2 2s in, 1 2 out, and then the 3 left over inside.
I have my
you have minus on that last one?
So 20 minus 2.
We all good to there? We're all good with all the 2-for-1, ship out, breakdown stuff? And now, are they all like root? Now the 2-for-1 stuff is over. Now we put on the like roots mode, right? We ask ourselves, are these like roots? Yeah, they're all the same roots, huh? They're all roots of 3. If they were different, you couldn't combine them. So 15 roots of 3 and 5 more roots of 3 makes 20. Minus 2 makes 18 roots of 3. 20 minus 2. Good on that. Questions? All right, you guys ready for more? Five root 18 minus 3 root 200 plus 3 root 50. Hey, that 200 in the middle, let me help with that 200 real quick. 200, I would go 2 times 100, and 100 is 10 times 10, and I would just stop right there. I mean, you of course, you could go 2525, but why bother? As soon as you got a match, ship it out. No need to go further. As soon as you find a matched pair at any level, even if it could break down further, go ahead and circle and ship out right there, just to save you some time and effort. So keep going. Break those, all 3 of those down.
18, they get minus 2.
Okay, so break down that 18. 2 times 9, 3, 3. So the 2 3's in. Two 3's in, 1 3 out. That's 15 roots of 2. 2 10's in, 1 10 out. 10 times 3 is 30 roots of 2. And 50 is 5 times 10. 5 times 2. 2 5's in. 1 5 out. 15 square root of 2.
You get 0.
They're all a bunch of square roots of 2. Now,
30 minus 30.
oh, it is 0. Now we add the numbers in the front. 15 and 15. I'll just skip over to 50. 15 is 30. Take away 30 is 0 roots of 2. Wasn't it 0? It's not 1. So it's 0 root of 2. But what is 0 times anything?
0.
The answer is just 0. So the answer is not root 2. Why is the answer not just root 2? Because that would mean 1 root of 2. Right? If you just write a root 2, that would mean 1 times it. It's 0 roots of 2. Notice this is a big fancy way to write 0.
These are here.
All that work for 0. Yeah.
I still think you have to forget about the nice gun.
If the pairs are going to be
They never covered it.
No, and is that like, how do I interpret that? Was my teacher cheating me? Like,
This one, it broke, right?
something that's like supposed to be covered or not?
Yeah, it's supposed to be covered. I'm only covering what the state of California requires.
Okay.
Yeah, or what WASC, the Western Area Schools and Colleges, so this is transferable.
Then how do I address the fact that my teacher last semester didn't even attempt to cover stuff?
Yeah, the person probably got behind and then didn't cover it. That's probably what happened.
So should the state ask for a
You can go tell the dean if you want. Shirley McManus, Dean of Math Science Engineering. You can let her know. That is helpful information. We want teachers who cover the material. All right. Good on that one. Questions? We good? All right, break down that 147. Just use your calculator.
I don't know, 7 goes in there.
It must be divisible by some. You're not sure. Yeah, 3. It's divisible by 3.
27.
For sure 3.
So, yeah, because if 3 is inside. 21 and 3.
Here goes Roberto, our class tutor. Come see him for help. If when's our exam next week?
Yeah.
Wednesday, I think.
Is that what it is?
Wednesday.
So, yeah, next Wednesday, right. Roberto knows. See, he knows. He's there to help you. Next Wednesday, see you, Roberto. It's going to be a hard one, right? Exam 5 is going to be another hard one like Exam 4. So get the help you need. He's available. I'm available. Come see us. We're glad to help.
Is it 21 to 3?
No, 21 times 7. Then you break it up.
So divide by 3.
You're right. 21 times 7.
Is it 3 times 49? And then that's 7 times 7. 2 7s in. 1 7's out. So it's 7 root 3 for that first one. So far, so good. Because the 3 has to stay in. Now, what about the 27? 3 times 9. 3 times 3. So the 2 3's in. Leaves 1 3 out. And what about x squared? What do we do with powers?
Bring the X out, too.
Cut the power in half. X to the 1 or just regular x, huh? What's left inside? Just the 3, just the other 3. Good so far. Is that making sense? James.
Since the 7 and the 3 are not like terms.
Yeah. We cannot combine those, can we? Because this one has an x and that one doesn't, right? Yeah, you're right. So to be like terms, you got to have the same roots and the same letters. Everything's got to be like, and they're not because one has an x, the other does not. Does that make sense on that? Let me type that in because sometimes Bittinger, the author of this book, does some weird things. Let me make sure you're going to take that in. 7 root 3 minus. So this is it right there.
Well,
Does he do parentheses?
yeah, it says the answers, it says it wants parentheses 2 minus 7x, root of 3.
Answer.
But 2 minus 7x is parentheses.
Well, I know we could do that, but my question is, will it allow you to not?
No, it won't, because I tried to put negative 7x
Just
plus
said it
2,
word anyway.
and it said it was wrong.
9.7.
I tried to do this,
Weak.
I tried to do negative 7x, no, well, it just sent me a different one.
Oh, that's
what I
can pull up my head.
I don't know.
So type in the answer.
Don't bother me. We have a test.
So 5 to 3.
Tell her we don't test it.
Yeah, and then minus. It's 9 root 3, so 9 extra 3.
Minus 9x root 3.
Nah, that's true.
You got it? Oh, okay. Yeah, anyway, let's move on. Let me just do this. The program's weird here. And I think she is right that it's going to make you, even though you cannot combine them, they're not like terms. And I and pretty much every math teacher I've ever met would just say, look, just stop. They're not like terms. You can't combine them. And they're not. You know, Bittinger's not going to say you combine. That'd be illegal math. That'd be not true. But he's going to say, hey, how about we factor now? And I'm like, why? Why are we factoring, Bittinger? But Bittinger wants you to factor all of a sudden. So he said, look, that you can take out a root 3. Well, yeah, but why are we doing that all of a sudden? So anyway, he just wants you to do that. So that's what he wants you to do. That's not combining. We still never combined them because they can't be combined. They're not like terms. He just said, hey, it'd be fun to factor now. So he just takes out a root 3 right there.
On the test, is it going to be finished, or do we have to start?
Yeah, I think you'll. Yeah, if it's on the test, it'll be this way. Now, there's only like 2 of these in the whole section. Don't worry, it's not like a major thing. We'll keep doing. You'll recognize it's multiple choice on the test. You'll look at this and go, oh yeah, if you multiply that, it's the same as that. You'll see it as multiple choice option, I think, right away. If you just look at it and say, oh, it would just multiply back in. You know, if they have this answer and you have this answer, you'll recognize they're the same on a test because you could just distribute that root 3 back in. So that's what Bittinger is going to require, I think. He's a little weird on this one. Yeah. He's the author. He's the one who wrote this book that we're using. Yeah, so anyway. Yeah, so it's not illegal or anything, but I'm like, why are we factoring all of a sudden? But anyway, he's just factoring those out. All right, let's keep moving. All right. Now this one's a little tricky because we have pluses and minuses inside the roots. Pluses and minuses inside the roots.
See, that's the form though that I want you to give the answers and show you right there. It's got the parentheses and then.
Or yeah, click like terms.
Okay. So, how are we going to do this?
49x cubed minus 47 x 7 minus.
You can't combine them.
Okay, so in this little world, factor out x squared. Good so far. What did I do? I'm factoring inside the root there. Remember factoring? Where you take out what's in common? So far, so good. See, if I was to multiply that x squared back in, think about if I was to multiply that back in, powers would add and it would go back. X squared times x cubed, powers would add, go back to x to the 5th. X squared times 1 would go back. I just looked at these two and I said, take out what's in common, x squared, and then put in parentheses whatever works. Whatever would add to go back.
I just keep it in here.
Does that make sense?
And we can test it.
So far, remember factoring, greatest common factor? That's GCF. Now what about the other one? What's the GCF for the other one? 49. Like that? That good?
So you could
Remember taking out the GCF?
see what you did there.
Now, so what can you do with the root of x squared? That's 2 x's in. Remember, you just cut the powers in half, 1x out. But the x cubed minus 1 has to stay in. Why? Because it's glued together. Remember that rule? You can never forget that. Costco, plus and minuses, this is all stuck together. So I can't send any more x's out.
Top 5 is just.
Let me slow down here. Here's where we start to get a lot of rules all kind of coming together at once. Old rules, new rules, lots and lots of rules. remember the Costco rule. Remember that pluses and minuses are a big pain all the way through algebra because they stick things or glue things together, don't they? Pluses and minuses glue things together. So that's why I couldn't write from the beginning, just go, oh look, just start shipping them out, right? Odd power, and no. They're all stuck together. You can't do any of that until you factor. Now, why does factor? Because see what happens when I factor? Now it's times. Now it's x squared times. That you can do. See how this x squared is not glued to anybody? He's like, I'm not glued. I'm just times. I'm not plus or minus anything. I'm just times. So you can do things with me. But other things that are plus and minus are all glued and stuck. And we can't do anything with them. Remember that? Never forget that rule. That's almost the most important rule in algebra. Pluses and minuses are like shopping at Costco, right? It's all package deal, glued together. Can't be, all the nice rules are out. You can't ship things out. You can't do anything when they're stuck together. So only the x squared can ship out an x. This other part's stuck together. Here the 49 can ship out a 7. The other part's stuck together. Root of 49 is just 7, right? Is that good to there? Now, one more GCF factoring. What do they both have? Yeah, the root of x cubed minus 1. What does that leave behind?
7x.
X plus 7. Right, this has to go to x, this has to go to 7 to go back.
It would just make more sense to have that on the other side of
Either way, you can put it in the front or the back. Yeah, and the answer thing, they put it at the back.
bracket.
Is that making sense what I just did there? You okay on that last step? These guys both had a root of x cubed minus 1. So I took it out, and it leaves x and 7.
Long road bed.
Oh, yeah, it's a messy one. A lot of room.
It's gonna be
Okay, I'm seeing.
parentheses,
I
x
just
plus
can't
7.
just-
Yeah, they just switched the order. It's the answer I have with the order switched. Right, see how they're giving you the answer? Right there you put in this. All right, let's keep going. Let's get through the rest of these. There are some tricky ones. We want to cover them well. All right, root of 6 minus root of 1. And this is going to be tricky because it's both root rules, the rules about roots, and fractions, which are can be tricky too. So we have the square root of 6
36
minus the root of 1/6. Now, what do you do? Let's figure this out. What do you do when you have a root on a fraction, the root of the 1/6? What's the deal with that?
It did treat them as individual.
Yeah, let's make them two roots. I like that. Good way to. Let's just make it root of 1 over root of 6, right? And can we leave it that way? Can we leave a root in the bottom, in other words? Got to rationalize it, which means multiply top and bottom by that root. So let's do that for. We won't do anything with the first root 6 for now. Let's just mess with the fraction at the back. Multiply top and bottom by root 6, right? Because we can't have roots in the denominator. Remember that important rule. No roots in the bottom, no roots in the denominator. So do that. What happens from there? Now we have root 6 minus. What happens on the top? 1 times 6 is just 6 inside the root, right? Insider with insider. How about root 6 on the bottom? A plain 6. Remember? The golden rule. 2 6s in the root, make the jailbreak, 1 6 out of the root. Okay, are we good so far?
But now you have a root 6 and a root 6. Can't we?
We'll get there. Everybody good to that point? Why can't we just stop right here? Because these guys are like terms. They're both root 6s, so we do have to combine them somehow. So let me give it to you in 2 phases. Phase 1 we just finished. Phase 1, well, I'm kind of scribbling now. Get rid of root from the denom. Right? We got rid of the root from the denominator. We can't have a root in the denominator. You multiply top and bottom by the root. That's what I did. right? Top and bottom by the root. Now, how am I going to subtract those two? How do you, well, how you tell me, what if I had 7 minus 1/3? It's just fraction thought. Now, our root thoughts are over. The rest of the problem is just, do you remember how to deal with fractions? We're not going to really do anything more fancy with roots. Just, do you remember how to subtract a whole number, take away a fraction? What do you do? Put it, make it look like a fraction. 7 over 1, and yeah, multiply top and bottom by 3 to make them common denominator, huh? Remember all that? Remember all that? So let's do that.
You scared me.
So in other words, we're going to come in here and go, okay, this is over 1. So phase 2, make denominators the same by multiplying top and bottom. So I got to make those two have the same denominator. So multiply top and bottom. But you got to do top and bottom, right? You got to keep the balance. Yeah, by 6. So what do you get then? You get 6 root 6 over 6 minus root 6 over 6. Good so far? Now they have the same denominator, don't they? See how we've done that? So now that they have the same denominator, you can subtract them, right? You just keep the denominator, whatever it is, and you take 6 roots of 6 minus, what's the number in front of the second root 6? There's no number. What does that mean? 1. There's really a 1 there. It's 1 times root 6, right? So 6 roots of 6 minus 1 root of 6? 5 roots of 6. There we are done. Question?
Okay, so you multiply the top, the 6 by the root 6.
Right?
How does it become not a root on the top or below that?
I multiplied by a plain 6, not a root 6. Good question, Carl. You see the difference? It's not what I was doing earlier when I multiplied top and bottom by a root to get rid of a root from the bottom. That's over. I did that on phase 1. On phase 1, I multiplied by root 6. Here I'm multiplying by plain 6, not root. Notice no root. Why? Because I'm not trying to get rid of a root. I have a totally different goal in
Go
mind.
back to what you.
My goal is not here. My purpose was I don't want roots in the bottom. So I got to give another root 6 because 2 of them will make a regular. That was the reason I did a root 6. Here my goal has nothing to do with roots. It just says, yeah, I can make the bottoms the same.
But wouldn't it remain the same on top though?
Unless you don't have space between them.
Wouldn't it still remain a...
6 times root 6.
I
Oh, you
see.
think
Your root looks like a five.
Oh. All right. Oh, it kind of does, doesn't it? Yeah, this is 6 root 6 over
He
6.
said it was.
You good there?
studying though.
Does that make sense?
Yeah.
I think I will forget this.
Questions I can answer?
The first two, miramos de nada.
Is that good?
It's next week.
All right. All right, let's try that one. So same thing. What's phase 1?
Get rid of the roots from the denominator.
So multiply top and bottom. So we have root 2 over root 5 minus root 1 over root 10. So multiply top and bottom to get rid of the roots. Right, so phase one, multiply top and bottom. So what do you, we're going to do top and bottom of this one by root 5, top and bottom of this one by root 10. Does that make sense? So whenever you have a root in a denominator, you multiply top and bottom by that root. Right? Good. It's always phase one. Multiply top and bottom by that root. Top and bottom. Is that good so far? Y'all happy with that? Does that make sense? Questions I can answer? See what I'm doing? So whenever you have roots in the denominators, you multiply top, right? I got a root 5 here, so multiply top and bottom by root 5. Got a root 10 here, so multiply top and bottom by root 10. Question, James?
I'm trying to figure out, because I get the top when you're going to step 2.
Uh-huh.
I get it to a jump.
Okay.
So
Does this make sense what's on the board?
I was going already with the 2. 5 times 2 for 10.
Good.
Times 1.
Times 1, where you get the...
Right here, you're going to go with 5 times 2 to make the denominators the same number.
So is this good? Does this make sense what's on the board?
Yes.
Questions I can answer on this so far? We good? Now, that's phase one. Phase one is over. Now for phase two, what do we do in phase two? Common, no, that's the wrong common. Common denom. You got to make the two denominators the same. Not roots. I don't care about roots. Roots are over. I got rid of the roots from the bottom. That's over. But now I've got to make the two denominators the same number. Huh? So make those two denominators the same number. So what number are you going to make them both? Yeah, so multiply top and bottom of this one by 2, huh? To make that denominator a 10 like the other denominator. Is that good? And I don't even need to mess with the second fraction. So what's going to happen on the top? Is that going to be root of 20?
No.
No.
Is he in jail?
No.
Outsider, insider. No interaction. It's going to be 2 root 10 over... Can they multiply 2 times 5? Yeah. They're just plain numbers. Is that good to there? So far, so good. I made the denominators the same now, huh?
So root 10 over.
So now, question?
Why is the 5 squared not multiplied with 5 squared on the top one?
On the top one, why do these guys not multiply?
Yeah.
They do. It's another way of thinking about it. What would be 5 times 5? Root 25. And what is the root 25? Plain 5. It's just another way to do the same thing. I just say 2 5s make a plain 5, but you could say makes root 25, which is plain 5 as well. Isn't that beautiful the way the rules always agree, whichever way you go? All right. So now, how do we finish this up? Common denominator is 10. I'll do that part. You do the top.
And it's 10 as well. Root
It's
10.
2 roots of 10 minus 1 root of 10.
So it's,
Right? Remember, when there's no number in front, it's a 1.
so
So it's 2 roots of 10 minus 1 root of 10. What is that?
root 10 over.
1 root of 10. Or just root 10 over plain 10. There it is.
I have a way harder one, can we do
Well, is it one of them further down the line?
No, it's number 10, it's just a different
All right, yours. Okay, I'll come by and look at your individual one. Good on this one? Questions on this one? No, we good? All right. So now we're going to start foiling these things. So we've got 6 minus root 2, 2 plus root 2, and we're going to FOIL. We're going to, you remember how FOIL works? First to both, second to both. Let me help with the signs to be really, really clear. This minus is on that root 2, and this plus is on that root 2, as you know, right? Just to be really, really clear with the signs. Okay, so we're supposed to FOIL. You know how it works, right? First, the 6 is going to go to both of those two. And then it'll be the minus root 2's turn to go to both of the other two. Now, when they go, what's the rule for multiplying? Outsiders with outsiders, insiders with insiders. The jail thing, right? Just make sure you keep that straight, and it'll all be good. So here we go. 6 times 2. That's an outsider with an outsider. 12. Plus 6 times root 2. Am I racing ahead of you? I want you to see this. So 6 is about to multiply the root of 2, right? I'm letting this 6 go to, he already went to the normal 2, made 12, and now he's going to the root 2 at the back. He's distributing to both. This 6 is an outsider, this 2 is an insider. Exactly. The 6 stays in the front, the 2 stays in. They don't make a 12, do they? Because of the jail rule. Good so far? So we're halfway done. That 6 has gone to both. Now let the negative root 2, let him have his turn, he'll go to both. Boom, boom. So again, we have the other 2's an outsider, this 2's an insider, they stay separate. Minus 2 root 2. And then root 2 times root 2. Oh, negative. It's going to be negative times positive. So negative times positive is negative.
Is it a 2? Is it the same?
Yeah, and they're multiplying, aren't they? It's root 2, root 2. So you could say it's root 4, which will be plane 2 in the end, or it's just jump right to plane 2. Either rule you use, it's plane 2. Did you catch that last step? So what I was doing is, what is a negative root 2 times a positive root 2? Negative times positive is negative. And 2 2's inside. Break the jail. 1 2 outside. Right? Or you could say, Mr. Trent, you said insiders multiply insiders. That'll work also. 2 times 2 is 4. Root of 4 is plane 2. Either set of rules will work.
Combine the like terms?
Oh yeah, we need to. We have one more step. You're right. Everybody good to there though? So now, here's what's tricky about these. First off, we're in multiplying mode. We just did that. Now you got to shift gears and put on your adding, subtracting thinking cap, so to speak. Go into adding, subtracting. So now, add, subtract. Okay, well, when you're adding, subtracting, it's like roots only. Right? Now we add, subtract, like roots only, which would be these two, and the 12 and the minus 2 are certainly like, they're just plain old numbers. So I'm adding, subtracting now. I'm shifting gears. The multiplying's over. The parentheses are gone. So now 12 add negative 2, or 12 subtract 2. 10. And then now these two, 6 roots of 2, take away 2 roots of 2,
Plus 4.
is 4 roots of 2. Done. Does that make sense? How I combine roots with roots and numbers with numbers. Like terms.
Debbie, on the test?
No, let's just skip it. No, I'm kidding, of course. Can I add these last two? Make 14 root of 2?
No.
You're right, I cannot. If that was 10 root of 2
Yeah.
and 4 root of 2, then I could add them, because then they'd be like, huh? But it's not. So they're unlike, and I'm done right there. Does that make sense? So for adding, subtracting, they've got to be like roots, don't they? If they're not, if one's a plain number and the other has a root, they cannot add. Is that okay on that? Shall we try? All right, try that one. Root of 2 plus 4. Root of 2 minus 4. So FOIL that. First to both, second to both.
be difference of squares, right?
It is, yeah. You recognize that, you think, right?
I had to restart my computer again. It's so frustrating.
Oh, so.
Okay, well, this is the one that I got.
Yeah. Wanna show me how to do it?
This point, like, it's gonna take me another 12 hours to like fully process everything I just learned. So I won't know how to do this until tomorrow,
Oh, okay.
which is really weird. Okay, but I have square root of 3.5.
You're right.
Could you do?
Oh, you did that. You put that space.
Oh, wait, so that was right then. That was wrong.
Yeah. I think it always has to be like that, yeah.
You're totally right.
So I just,
So, I'm gonna times this by root 5, and by root of 5.
plus 4?
So, I have 3, 5 over 5.
Hold on, was that in or out?
It's out.
You sure? Because mine look right.
Yeah, no. My side is good.
My shit looks like an equation that no one can solve. Not even Einstein. Nah, probably true. If you got 2 and a 2, they can cancel if you want.
Okay.
You could get, why'd you get negative?
You got negative 2.
It's good. So the next
It's positive. Good. We'll see.
You want to get rid of the root on that one too, though, right?
Oh, yeah. This is 1 root 15. Pretty much. 7. And this is
What's the denominator on that second?
You're here, look. Because this and this is cancel. And this make negative 14.
But now we don't cancel anything no more. So why did this cancel?
Which one?
These two. Exactly.
Which one?
I'm still different denominators.
What is that? I can't even read that.
Oh, it's different. That's different at 2 there.
Exactly. These are the same. These are opposites. Negative 4 square root of 2 plus
How'd
4
you
square
get
root of
2?
2.
Look at the square root of 2.
Square root of 2 times square root of 2.
What is it?
2.
How'd you get that 4 though?
4.
4 square root of 2. Oh,
You
and
multiply this and
Am
this.
I timesing it by the root?
so you get what, 8?
What are you weird? No, you don't get 8.
We get it there. Same shit?
Plus 4 square root of 2. Minus 16.
Oh, you're onto something. You're a magician.
And then those two cancel out.
Are you sure? Alright, keep that one.
So that's,
But that mine was
It's the
right.
difference of 2 squares.
Oh, yeah.
That's it.
You're onto something. You got some straight facts. That's what it is.
6.
Okay. See, root is only over the two.
Why were you in New York at
So that's real important.
Because the 10s, they're dead end.
All right, so, yeah, notice the root stops at the 2. Don't let it spread to go over the 4. Don't let it go like that. That'd be a different situation, right? That'd be a different problem. So, all right, so we know the rules here. The first one goes to both. So, root 2 times root 2. What is root 2, root 2?
Regular 2.
Plain 2. Because 2 2's in, make the jailbreak, 1 2 out, right? When they're multiplied. 2 root 2's multiplied. And then root 2 times negative 4 is negative 4 root 2. They stay separate. The 4's an outsider, the 2's an insider. No crossing the line. The guards get real upset about that. Right? And he's done. Now first one, we're halfway there. Good. So now the 4 is going to have his turn.
The same.
He's going to go to both. Plus 4 root 2. Again, they don't make 8 because they don't get together. The 4 is an outsider, the 2 is an insider. There's no crossing the line. And 4 times 4 is 16. It's minus 16 because it's positive times negative.
So they canceled.
Yeah.
At least it's the same.
We good to there? Good so far with that FOIL? So multiplying is over at this point. There's no more parentheses. We go into adding, subtracting, and clearly those 2 in the middle cancel, don't they? They're opposites. So it's 2 minus 16. It's negative 14. That means all of this is a fancy way to say negative 14. Are we good there? Questions on that one? Okay, so 7 roots of 3 minus 6 root 3 plus 1. So keep the inside, keep the rule straight. Inside stuff with inside stuff, outside stuff with outside stuff. As you FOIL. Inside will play outsiders with
Turn
outside.
this with these.
Could happen.
Or
I think that's 1.
Or it's 7 times this and then.
Oh, no,
they're wrong.
they're together.
Yeah, they're
Okay.
together.
Yeah,
They're together.
So it should be what, 7 root 3?
Yeah. So 7 root 3 is one term.
It's gonna be 21.
7.
Yes, it is. So this 7 root 3 will travel and hit the root 3.
7.
And then it'll travel and hit the 1.
Just 3.
So the 7 root 3
7 times 3.
travels together.
21. Together. Multiply.
7 root 3 is one term.
Yeah.
Oh, so it break.
7 root 3.
So
Yeah.
it needs to break out.
Times root
Break
3.
3 and then multiply to the 7.
Right? We're multiplying right now, right? We have
Plus
parentheses.
7 then.
Gonna be what? Yes.
So 21 plus 7 minus 6.
What are those 2 3s in the roots gonna do? 2 in,
Minus 6.
break the jail, 1 out. Those 2 root 3s are gonna make 1 plain 3. Times 7. 21.
21 plus
Everybody see that?
7 minus 6 minus 6. So 16. Root
Everybody see
3.
what's happening on that first step? 7 root 3 times root 3 makes 7 times plain 3, 21. So it's 21 plus 7 root 3. He's done.
Yeah, it was 22 minus 6.
We good so far?
Oh, it's the same thing.
And then the minus 6 goes to both.
Minus 6 root 3.
Minus 6 root 3, and then minus 6 times 1 minus 6.
So 16 root of 3.
Does that make sense? Well, the main thing is when 2 root 3s get together, they make a plain 3, don't they? So now the
Here's 21.
parentheses are gone, the multiplying's over, change into adding subtracting mode, which means like roots.
So 7 root 3 minus 3 root 3.
Which is just 1 root 3 or just root 3.
Root 3. Right?
That's right. And what about the 21 and the minus 6? They can combine their.
Well, that's 15, right?
Yeah, it's 15. Yeah, 15.
Plus root 3.
Plus 1 root 3 or just root 3. Totally. And that's it. And they can't make 16, can they? Because that 15 doesn't have a root 3. They're not like. So they just stay separate. Because they don't both have the same root. So they just stay separate. Yeah, you don't have to put that 1 on there. You could just say root 3. That good?
Oh,
That's making sense? So when you multiply, it's outside with outside, inside with inside. Then when you add subtract, it's like roots. We're kind of doing both, which is good practice for the test. Because both things are on the test. No questions? Keep moving. Process of this section. All right. 5 over root 6 minus root 11. This one's going to present a little bit of an issue. Now let me change the problem for a minute. What if I had, well, let me not. Whoops. Okay, 5 over root 6 minus root 11. So I have that fraction. And what do I want to do? I want to get rid of the root from the denominator. Right? Remember that's what they're saying, rationalize the denominator. Get rid of the root from the bottom. Now the problem is, I have two roots. And not only that, they're glued together. Remember? Plus and minus is a big problem. Those are glued together. So we got to do a whole special thing. Let me write it over here. When square root and plus or minus in the denom, when you've got that, which is what we now have for the first time, you must do a special thing. Multiply top and bottom by the entire denom, because it's all glued together, with opposite sign in the middle. So in other words, I've got to multiply by root 6 plus root 11. Top and bottom. See how I'm using the opposite sign in the middle? If the original sign had been plus, then I would be doing minus over minus. You do the opposite sign. Whatever sign is originally there in the denominator, you do the opposite. So if there's originally a minus, which there was, I'm going to do plus on the top and the bottom. It's a special trick. This has even got a name. It's such a specialized trick. It's called the conjugate. I'm not going to quiz you on the name, but in case you want to know, in case your Math 103 teacher mentions it, you'll know what here she's talking about. The conjugate. It means opposite sign in the middle. That's the only thing that'll handle it. Conjugate. All right. Are we ready? So now on the top, we're going to distribute. Remember what happens. Keep in your mind the rule. Outsiders with outsiders, insiders with insiders. So we get 5 root 6 plus 5 root 11. Good. What about on the bottom? On the bottom, how about, what we do on the bottom? Well, this guy's going to go to both. Right, it's a FOIL on the bottom. We just did 2 or 3 problems with FOIL, so we just do that now on the bottom. So what's root 6 times root 6? Plane 6. Remember the jailbreak. 2 of the same is 1 plane outside the root, right? Root 6, plane 6. Good so far? Question? Car?
You have positive in there to multiply by. Are you doing that to keep the negative?
So many.
Yeah, we'll see why. Something special will happen. Yeah, so I'm using the opposite sign on purpose. Is that what you're asking about?
Yeah.
The original sign was minus. I'm using opposite sign. Yeah, that's a really important part.
So if it was a plus instead of negative.
Originally, I would use minus top and bottom. Always use the opposite. We'll see why in just 2 seconds here. So, ready? So root 6 is plane 6. Root 6 times 11 is root of 66. Inside, right? Because the 6 and 11 are both insiders. Insiders multiply insiders. He's done. We're halfway done with that FOIL on in the denominator. Good so far? Now the minus root 11 will go to both. Minus root 66. Right? Again, insider times insider. And now, minus root 11 times plus. Negative times positive is negative. Root 11, plane 11. 2 in, 1 out. Right? That's the golden rule of roots for the whole chapter. 2 11s in, 1 11 out. Are we good so far? You good with that FOIL on the bottom and the distribution on the top? Outsiders with outsiders, insiders with insiders. Now, why are we doing all this? What were we trying to do? You're trying to get a bachelor's degree. They made you take this math class. No, I don't mean all that. But I mean, what are we trying to do on this particular problem? I'm getting too wide, too big picture here. They're getting rid of the root from the bottom. Now, we still got roots on the bottom. I thought we were trying to get rid of the root from the bottom. Yeah, and why did we get this allowed, do you think? That's why we use the opposite sign. Because that's what makes these guys go bye-bye. That's why we use the conjugate, which means opposite sign. Because it'll make the opposite sign. And it'll be 0 and the roots will go away. That's the trick. All right, what do we got left then? 5 root 6 plus 5 root 11 over 6 minus 11? Negative 5. That's weird. Can we stop there? Can we cancel the 5s? Or how many 5s? Like all 3 5s? Just 2 of them? What's Costco have to say about this? They're a package deal. Costco says, don't you be touching this 5 unless you're ready to buy the whole package. Don't you walk out of this store with just part of a glued package. So we know it would be illegal. I hope you know. It would be illegal to just cancel those 2. Why? Because this is a package and you're only buying part of the package. So what do you have to do? Buy that part too. Right? We can't do by the way, we can't do the roots. That's a whole different world. Don't worry about 6 and the 11. They're in a different world. But all 3 5s all at once. What do I mean all? They divide them all by 5. It's like reducing a big fraction, but all the parts that are glued together in the top. Divide by 5 leaves a 1, leaves a 1, leaves a 1. So we get 1 root 6 plus 1 root 11 over negative 1. We canceled all of them because they were glued, right? It's all or nothing. We did them both.
So the answer would be...
Hold on, one last thing. Do we ever leave 1s on the bottom of anything? No. So we got to get rid of that 1, but it's not just a 1, it's a negative 1. So it'll divide both of them by negative. So it'll switch both signs. So this over the negative 1 and that over the negative 1. It's negative. I'm totally running out of room here. Bring it over here.
But you don't need to keep the ones in front, right?
Right. So it's negative root 6, negative root 11. Done. Don't even need the 1 in the bottom, but it was a negative, so the negative was under both of them, right? That bar was, negative was under both. So the negative changed both signs. And now we're done. What did we do? We got rid of the root from the bottom. In fact, there's no bottom at all anymore. We'll do several of those in the next 15 minutes, so as many as we can. That first of those type makes sense. So when you see roots in the denominator, you multiply top and bottom by opposite sign in the middle, called the conjugate. Ready for more? I told you this was a messy section. It started so nice, didn't it?
Indeed.
Okay, so 8 over root 14 plus 1. So there you see it. Root in the denominator, right? A square root and plus or minus in the denominator. Multiply top and bottom by opposite sign in the middle, called the conjugate. Right? As soon as you see a root, it's how you recognize it on the exam. It's going to take practice. It will not come to the casual. You have to practice this. It's how you recognize it on the exam when you see a root and a plus or minus in the denominator. So what am I going to multiply top and bottom by on this one? Root 14 minus 1. Does that make sense? Opposite sign in the middle. So the 8 will distribute. Is that good on the top? I just distributed that 8. And on the bottom, can you do the FOIL? bottom. So the root 14 goes to both. What's root 14? Root 14? Plane 14. Two 14s in, one 14 out. Golden rule of roots. 2 in, 1 out. Plane 14, right? Minus 1 root 14. This one's an outsider, that 14's an insider. No interaction. He's done. And now this guy, boom, boom. Plus 1 root 14, minus 1. Is that good to there? So far? Everybody getting that? Okay, so now on the bottom, we have the roots canceling, right? That's why this works. That's why we do 1 plus 1 minus, because it makes the roots cancel on the bottom. So we have 8 root 14 minus 8 over,
13.
yeah, 14 minus 1 is 13, and we're done. What did we do? We got rid of the root from the bottom.
Oh, that was simpler.
That was a little easier than the last one, huh? Question?
Why did you go a step farther than the last one?
Yeah, the last one, the 3 numbers reduced. They were, yeah. Now, let me give you a heads up. What if this was like 16 instead of 13?
Then it's reduced.
I would reduce it. But it's got to be, again, this is Costco glue on the top. So you can't do just one of these. You got to do both 8s in the 16. You would divide all 3 by 8. You look at 8, 8, 16. You say, what goes into all 3? 8 would. You divide them all by 8, leaving a 2 on the bottom. But 13, he's like, I don't divide with 8. I don't go into 8 at all. I'm done. Right here. Because 13 does not reduce with 8. Make sense? All right, let's squeeze. So 9 over 6 plus root x. All right, same thing. You see a root in the denominator along with a plus or minus. What are we going to multiply top and bottom by?
6 minus root x.
6 minus, right? Opposite sign in the middle, huh? Opposite sign in the middle. So distribute on the top, FOIL on the bottom. Good things should happen. Take that 9. Good on the top.
Oh, this is different.
Now on the bottom, it's a FOIL, right? First to both, second to both. So the 6 goes to both. So 6 times 6, that's just 36, just normal number multiplication. Minus 6 root x. That good so far? The 6 is an outsider, the x is an insider. They stay separated. And then the plus root x goes to both. Plus 6 root x. And then what happens with positive root x multiplying negative root x right here? Negative root x? Plain x. No longer in a root, right? 2x is in, 1x out. Is that good? Positive times negative is negative. And then these guys cancel, like they always do. And what do we got? 54 minus 9 root x. Clean that up. Over 36 minus x. We did it. We got, what did we do? We got rid of the root.
But doesn't 9 go into all those numbers?
But not this. Well, there's really a what here? A 1 there. Good question. There's really a 1 there, and they're glued. So they're saying, don't you mess with that 36 unless you mess with me. I'm a package deal. And nothing goes into 1. Good question. If it wasn't for that, we would do that. You're right. Good observation. Almost. Completely right. But the 1 stops it. Is that good? So we just stop right there.